right, good afternoon, everyone. I've got noon on the East Coast on my calendar, or on my clock, so let's get started. But first, can I get confirmation you guys can hear me?
Yes.
Yes, we can hear you, Lisa.
Awesome. Thank you. I wanted to make sure I wasn't still talking with the mute on. So for those of you who haven't had a chance to meet me, I'm Lisa Thaley. I am the chair of the Young Member Council. And so I get the privilege to kick this off very, very quickly with a couple of announcements for everyone, just with what's going on with SAME and the council. We have our next council call, which is open to any young member within the society or anyone who's just a young member at heart within the society if you want to join us. That will be next week on Thursday the 14th, starting at noon Eastern, and those usually run about 30 minutes. Things you'll hear about during that call, we are going to release another review for call for presentations for JETSI. So what that'll allow is any young member who's interested in speaking or putting in an abstract to speak, getting paired up with another young member who has spoken before to help review that abstract, help answer any questions, demystify the process, and just have a shoulder to lean on. So watch for more instructions on how to get engaged with that program probably within the next couple of days. Other things coming up, if you have a recent recognition that you've received, a promotion, an award, project award, anything of that nature that you want to highlight in TME, the Military Engineer, which is SAME's magazine, let me know or get on our website, and there's some information to get in contact with Wendy Parker, who is our Vice Chair of Mentoring and Recognition. Also, if you have a cool event or an article you just want to write to share with young members, we can help you coordinate that for potentially TME or definitely our young member newsletter that goes out every couple months. So feel free to reach out to me or reach out to Yvonne Simon, who is our main communications person. And then lastly, something else that's coming up that's exciting at the national level, SAME is working on a leadership development program. So in the next week or so, you guys will see a survey come out of what you'd be interested in. Please, if you have any interest at all in a national level leadership program, respond to that survey. Let us know your thoughts and your needs, because we're going to use this to really benchmark that new program. So that is all I had. So I'm going to turn it over to Jeff Duguid, who is our Vice Chair of Professional Development, and he is the mastermind who set up today's excellent topic. So Jeff, that is all I have.
Thank you, Lisa. Again, my name is Jeff Duguid, and today joining us we have 4 excellent speakers who are coming to us from the Army Corps of Engineers Memphis District. Our first speaker is Miss Elizabeth Burks, and she serves as the Chief of the Project Development Branch and Assistant Deputy of the Project Management for the Memphis District. She also serves as the Regional Project Manager for the Mississippi River Channel Improvement Program for the Mississippi Valley Division. And Miss Burks is joined by 3 other presenters, Mr. Chris Boko, and he became the Inland Navigation Economics Regional Technical Specialist for the Mississippi River Valley Division in August 2016. Chris works on navigation studies covering waterways all over the country. Mr. Zachary Cook serves as the Mississippi River Channel Improvement Project Manager for the district, and he has worked as a design engineer in the River Engineering Design section of the Hydraulics and Hydrology branch, working his way up to a senior engineer position in 2011. In 2016, he was selected as the project manager for the Mississippi River Channel Improvement Program. And finally, but not least, is Mrs. Vicki Watson. In 2014, she was selected to become a project manager in the Project Operations branch. In that position, she has been responsible for the Memphis District's 10 shallow draft harbors located in Kentucky, Missouri, Arkansas, and Tennessee. She also oversees the district's Mississippi River and Mississippi River dredging program in the district's Navigational Business Line Manager. So thank you all for joining us. At this point, I'm going to turn it over to Ms. Burks to kick off the presentation. And as she's going through her presentation, if you have any questions that you'd like to have her address, please type them into the chat window in your GoToMeeting box, and they will be watching those and will try their best to answer those questions as we go along.
You want drop down to there's that chat there. Okay. Yeah.
Okay, take it away.
Hey, thanks, Jeff and Lisa. We really appreciate the opportunity to be with everybody today. So just we'll go ahead and get started quickly. Welcome to our presentation on living with the river, infrastructure, and economics on the lower Mississippi River. Again, my name is Elizabeth Burks, and I'm the project manager for the Regional Channel Improvement Program on the lower Mississippi River. And what we're defining as the lower Mississippi River is actually the confluence of the Ohio and the Mississippi River that begins in Cairo, Illinois, all the way down to the Gulf of Mexico. It's roughly 1,000 miles. And you're right, I have 3 experts with me today, and we're going to share the presentation. Chris Boko, again, is an expert on the inland navigation, the inland waterways, and then and Zach and Vicki are experts on the lower Mississippi River. So we're going to talk first about the inland waterways and then how infrastructure on the lower Mississippi has turned the river into an economic artery for the nation. It offers reliable navigation and flood protection that's envied throughout the world. All right. Okay. So the next slide that you see is a picture of the Mississippi River watershed and its subbasins. The river drains 41% of the contiguous U.S. from its start in Lake Itasca, Minnesota, to the Gulf of Mexico. From start to finish, the Mississippi River covers a distance of roughly 2,350 miles, and it's the 3rd largest watershed in the world. I also want to point out the lower Mississippi River. I'm hoping that you can see my pointer. The lower Mississippi River watershed is in yellow. And so we're going to start out talking about the larger basin and then drill down into the infrastructure of that lower Mississippi River basin. And you'll find that we're super excited about the Mississippi River. We're very passionate about it. So we do invite you to ask questions. We really see the river as it's fascinating. It never ceases to amaze us as how dynamic and ever-changing it can be. So we've seen a lot, and there's a lot that we've heard over the years. So we're always impressed. But typically, when most people think about rivers, they think about boating, fishing, recreational activities. In our case, we really think of navigation and flood protection, and that's a big jump. And so we're going to share a little more with you today about navigation and flood protection. All right, before we jump into that, I want to switch gears a little bit to talk about the interstate system. Now, our interstate system moves us from point A to point B throughout the country. We're all familiar with infrastructure that makes up our interstates. We've got roads, bridges, exit ramps, on-ramps, things of that nature. But there's similar infrastructure on our rivers, things that we typically don't think about. So our ports and harbors are like our on and off ramps. And then our revetments, dikes, dredging, that's infrastructure that typically goes unnoticed. So on the lower Mississippi River, we often call that unnoticed infrastructure, hidden or invisible infrastructure. Without this infrastructure, our waterways would not be reliable, and that's the point we're going to make over and over again. So the lower Mississippi River would migrate tremendously, and then in drought conditions, ships wouldn't be able to move upriver or downriver. So I just want to make the connection, and I hope that you think about that throughout the presentation, that the similarities between our interstates and our waterways and the infrastructure that has to be there with both the interstate and the waterways to make them successful. And just like our interstates need maintenance, our waterways will need maintenance. Okay, so now let's get back to the Mississippi River. Here I want to point out the larger red circle that talks about the inland waterways, and that's what Chris is going to talk to you about, that larger system, the tribs, the Upper Miss and the Ohio River and their tribs that collectively come together for navigation and then down through the lower Mississippi River to the Gulf. And then we're going to talk specifically again on the lower Mississippi River, which is that yellow circle, with regards to the infrastructure that we have there, that hidden infrastructure. And with that, let me go ahead and toss it over to Chris, and we'll talk about navigation economics.
Thank you, Elizabeth. My name is Chris Boko, and I've become an economist for the last 6 years with the Corps, and dealing mostly with this hidden transportation system that Elizabeth talked about. So my purpose today is just kind of give a brief overview and an introduction into this. Next. So as Elizabeth kind of talked about, why is the inland waterway system the hidden system? Well, it's because you can see and feel the trucks on the road as you're driving down on the interstates. You can hear the trains or even have to wait at a crossing for a while. But people don't often notice as the tows are moving past them on the river. So I'm going to introduce you to this hidden system through answering a series of just kind of basic questions. Okay, the first question. So next. First question is, what is the inland waterway system? So you'll see this slide kind of shows what Elizabeth was talking about, and shows all the inland waterway systems throughout the U.S. Spread mostly in the East and Midwest, but you also have the Columbia Snake in the West. You also have the Gulf Intercoastal Waterway along the Gulf, and then the Atlantic Intercoastal Waterway stretching up from Florida all the way to Virginia. This is nearly 12,000 miles and authorized for 9 feet or greater. So the yellow lines will represent the shallow draft portions, so that's less than 14 feet. And the blue sections, one on the lower Miss and one actually up on the Columbia, represent the deep draft portions, which are greater than 14 feet. So navigation is a primary Corps mission and is the largest business line for the Corps. This means that the Corps is responsible for maintaining 193 locks with 239 chambers. These locks help the navigation system overall handle over 600 million tons of commercial cargo per year and is vital to the nation's economy. Next. So now that we've covered how did the inland waterway system come to, or what is the inland water system, now we'll ask, well, how did it come to be? Well, as you can see in these pictures, this is the Ohio River at Cincinnati. So the water levels, before the dams were built, the water levels fluctuated greatly, depending on whether it was droughts or heavy rain conditions. This picture shows that at Cincinnati, the water depth was so low that somebody could walk across from Ohio to Kentucky without even having to go over a bridge. So Congress recognized that interstate commerce needed to be able to travel on these rivers all year round. So using the authority of the Commerce Clause of the Constitution, Congress tasked the Army Corps with building and maintaining the inland waterways system. Next slide. So this next slide is a figure that shows the major waterways throughout the U.S. And then Elizabeth will just keep on clicking through, and you'll see the progression of the projects being built all across the country. So it started in the early 1800s, just trying to get the waterways to a navigable level. And then after the Civil War, the Corps began suction dredging and building jetties along the waterway. Then in 1885, the first of the 46 locks and dams were built along the Ohio. And then the present system of locks has been constructed over time. You can see the Columbia and Snake, a lot of them were built in the 1960s and 70s. You had the Arkansas River, which was built in the 60s and 70s as well. The Tom Bigby, Tennessee, which goes down to the Gulf through kind of Alabama, Tennessee. That was built in 1985. And then you have the Red River over those locks and projects over on the other side, over by Arkansas. And the current project about to be completed is Olmsted Lock and Dam, which is right above the confluence of the Ohio River and the Mississippi River And Olmsted will actually be replacing the Ohio River Lock and Dam 52 and 53. Next slide. So now that we've asked, okay, what is the inland waterway system and how did it come to be? Now we're going to say, well, what's moving on it? So an average of 482 million tons has moved on the Mississippi River since 2007. With an average of 170 million tons since 2007, the main commodity group moving on the Mississippi is coal and petroleum, petroleum coke. Petroleum coke, for those who might not know, is the solid material left after oil refining. Coal traveling on the waterway is usually either being brought down to New Orleans from the Midwest or Appalachian region for export, or it could actually be being delivered from the west, from mines in Montana to power plants in the east. And it can also be brought to steel mills on the Great Lakes, so going up. So those movements are occurring all throughout the system. The food and farm group, another key group is the petroleum group, and this includes gasoline, ethanol, crude oil, and other products. Petroleum products moving on the waterway could be delivered to cities such as Nashville from the refineries on the Gulf Coast, or it could be a movement of crude oil from the Bakken shale mining operations in North Dakota to the Gulf. So that would be going, they'd rail it from North Dakota to the upper Miss or the Missouri and then ship it down. The food and farm group, which includes corn, wheat, soybeans, and other food stocks, usually come from the Midwest and then are being sent to the Gulf for export. You also have, you'll notice the Columbia was on the far side. You'll have a lot of corn and materials being brought in the Washington State region and Idaho region, being brought to the river, the Columbia and Snake Rivers, and then being shipped for export out of Seattle. And so this kind of figure shows you what the levels of the commodity are. But what's not apparent, or what you might not have realized, is that the majority of the commodities traveling on this waterway are what's known as raw commodities. Raw commodities they're not like your finished products. They're not the electronics. They're not housing materials. They're raw commodities because raw commodities are not usually time sensitive, and they can handle the moving on the waterways. They can handle maybe potentially getting wet or the colder in conditions that could occur on the waterways. Next slide. So now we know what's moving on it. Why are they moving on it? Well, in one word, efficiency. One barge can hold up from anywhere from 1,600 to 1,750 tons, and actually even up to 2,000 occasionally, depending on the draft of the water. So a 15-barge tow can hold 24,000 tons to 26,000 tons. This is the equivalent of 240 rail cars plus 6 locomotives, or 1,050 large semi-tractor trailers. This ability to carry more results in inefficiency. And another reason the barges are more efficient is because truck and rail often expend a significant portion of their energy for non-revenue purposes. For example, rail will expend almost half of its energy for not actually moving the freight. More than 30% is used for an empty backhaul. About 4% is reportedly lost or spilled each year. About 4% is consumed in just idling, and 10% is used in the locomotive yards, assembling and switching the cars. Truck moves will also often occur empty. So you'll have a truck ship from point A to point B with a commodity, but then it'll have to go over to point C to pick up another one. For the barge system, often you'll have a move that goes down the waterway, and then we'll go back up the waterway, both filled. Next slide. So efficiency is the main reason, but what does efficiency mean? Well, efficiency means lower cost. As noted by Peter Zehan in the book, The Accidental Superpower, he estimates that transporting goods by water is 12 times cheaper than transporting goods by land. The ability of the rivers to transport commodities at a lower cost benefits consumers in a multitude of ways. For example, a loaded covered hopper barge carrying wheat carries enough product to make 2.5 million loaves of bread, or the equivalent of 1 loaf of bread for almost every person in the state of Kansas. Also, a loaded tank barge carries enough gasoline to satisfy the current annual gasoline demand of approximately 2,500 people. Moving commodities over miles of navigable waterways also benefits the U.S. in other ways. Transporting commodities by barge helps avoid an addition of 49 million truck trips to our highways annually. In terms of rail, transferring tonnage moved over the inland waterway system would amount to an additional nearly 16% more tonnage on the rail system. Now, you may be thinking 16%, that's not a great number. I'm sure the rails can handle that. The problem is the fact that the rail system has capacity, a lot of it's in the west. And if you notice previously, the majority of the inland waterway system was in the east. So you're going to take if you moved all the tonnage from the waterway system to the rail, it's going to be mostly in the east. So you're taking already a lot of capacity level rails or high level full rails and then adding on to them even more tonnage. And then not to mention what the capacity of many of the highways is currently. Can you imagine? I've traveled on 81 in Virginia, and there's constantly trucks on there, and there would be even more nowadays. Next slide. So what's another reason why commodities might be moving on inland waterway system? Now we know that it's cheaper, but there also may be some like physical constraints, what are known as unique moves. There are some nuclear power plants on the Missouri, and they will have to get their generators on the river. It's definitely much cheaper, and having to ship them any other way would cost, they would have to actually build them at the sites and would cost hundreds of millions of dollars. You could also have coal silos. In the upper left, you'll see some coal silos and air ducts for power plants. And it's a lot cheaper to move them on the waterway, but at the same time, it's not physically possible. They would actually have to break them apart into components, ship them separately, and then assemble them at the site. NASA also has rocket boosters that they ship between the Gulf and actually places in Ohio. And the Delta Mariner is the vessel that you can see in the upper right. And that'll actually move between the Ohio and the Gulf back and forth. And then you have drill rigs, materials for drill rigs out in the Gulf Coast. So you can kind of see the large piece in the picture on the right. They would actually have to assemble that out there in the ocean. And then finally, we have military moves. We have sometimes military moving trucks and other equipment just on flat barges up and down the waterways as a more efficient means of getting their troops to different locations, or the equipment to different locations. And now I'm going to pass it off to Zach, who will take you more into a discussion on the waterways. Thank you.
So good afternoon, everyone. This is Zach Cook. I'm the Channel Improvement Project Manager for the Army Corps of Engineers here in the Memphis district of the U.S. Army Corps of Engineers. And what I'm going to do today is briefly discuss with you some of the technical considerations from an engineering standpoint on the lower Mississippi River, and discuss with you some of those hidden infrastructure items that the Army Corps utilizes to help focus on our navigation and flood risk management missions here on the lower Mississippi River. So as Chris discussed, the various methods and means of how we transport goods up and down the Mississippi River, I just thought it would be interesting to show you guys what a typical large towboat on the lower Mississippi River looks like. As you can see here, it's roughly 2/3 the length of a football field. So for those of you that are football fans, imagine a towboat filling up roughly 2/3 of a standard football field. Pretty large piece of equipment there. Most of these towboats are very large in horsepower so that they can push a large quantity of goods up and down the river. As Chris stated, efficiency is key, and being able to move these goods quickly and cheaply is the name of the game when it comes to moving goods up and down the river. This is a photograph of the largest towboat to ever have moved goods on the lower Mississippi River. As you can see in the picture here, this towboat was configured in a method that's roughly 9 barges wide by 8 barges long. So what you're looking at is approximately a tow configuration that is as wide as a football field and as long as 4 football fields. So quite a massive configuration for moving goods up and down the Mississippi River. This photo is a little dated, but this is a picture of this particular barge configuration and towboat moving goods through the Memphis Interstate 40 bridge crossing here in downtown Memphis, Tennessee. It was carrying 72 barges in a 9x8 configuration, which is equivalent to approximately 4,176 tractor-trailer trucks full of goods. The name of this boat was the Miss KD, and this particular picture was taken in the late 1990s, and so just quite a large operation that's ongoing out there on a daily basis, moving goods up and down the river. Now let's talk a little bit about the lower Mississippi River itself, what we call the mighty Mississippi River. For those of you who may not be aware of the force of the actual river itself. So the maximum flow rate, the maximum volume of water that can be moved or that is moved by the Mississippi River is approximately 2.1 million cubic feet per second, and that's the maximum flow rate. That's roughly equivalent to enough water to fill the New Orleans Superdome 2 times every second. So just think about that for a minute. Enough water, a volume of water moving past a particular point on the Mississippi River to fill up the New Orleans Superdome twice every second. It's kind of hard to wrap your mind around that, but that's the volume of water that would be flowing past a given point during a maximum flow condition on the lower Mississippi River. The river itself is a natural alluvial river, which carries sediment and a very large sediment load. There's roughly 240 million tons of sediment that it moves each year, and that's approximately equal to about 213 tons per square mile of the contributing drainage area. So as you all know, the Mississippi River Basin drains roughly 41% of the contiguous U.S., and that's enough sediment to the contributing drainage area to account for 213 tons per square mile of that drainage area. So quite a bit of sediment. So as you know, rivers in their natural state want to meander, and as they meander, they drop sediment out. And so some of that hidden infrastructure that the Army Corps is responsible for assist in helping us to maintain a safe and reliable navigation channel on the lower Mississippi River. So let's talk a little bit about some of the technical aspects of this infrastructure on the lower Mississippi River. The map that you see here on the right is a map of the boundaries of the Army Corps of Engineers lower 3 districts on the Mississippi River. The area highlighted in purple is the boundary or footprint of the Memphis district, which is the northernmost district on the lower Mississippi River. The Memphis district, as Elizabeth stated at the beginning of the presentation, the boundaries on the river begin at the confluence, which is the joining together of the 2 major rivers, the Ohio and the Mississippi River. This confluence is near the southern tip of the state of Illinois, near Cairo, Illinois. So roughly you're looking at this area here that I have the mouse pointer at on the screen. That's the upper limit of the Memphis district boundaries and the confluence of the Ohio and Mississippi River. So again, as she stated, the lower river stretches from the confluence down to the Gulf, past to the head of passes south of New Orleans, Louisiana, in the Gulf of Mexico, which is approximately 1,000 river miles. In the middle here, you'll see the Vicksburg district boundaries, which are highlighted in blue, and the yellow outline is the New Orleans district boundaries. So the three lower districts work together for this navigation and flood control system on the lower Mississippi River. Channel improvement, which is the term that we use, the technical engineering term that we use for assisting us in maintaining the navigation channel. It consists of stabilizing the riverbanks of the Mississippi River to a desirable alignment and obtaining the most efficient flow characteristics, which are width of the channel and depth of the channel, for flood control and navigation by means of revetments, dikes, and dredging. So channel improvement itself provides navigation on the river, flood risk management, and we also do this in an environmentally sensitive manner. So some of the infrastructure that I'll be discussing over the next few minutes. Dikes. Dikes are stone structures that are used to contract the channel width to produce the desirable navigation dimensions. Another one of our infrastructure features is called revetment. Revetment is a combination of steel reinforced concrete and riprap stone that is placed against the banks of the river to protect the riverbanks from erosion and help maintain the alignment of the river itself. So what is our purpose? Mississippi River and Tributaries Channel Improvement. So the MR&T stands for Mississippi River and Tributaries Project. This was a project that was authorized by Congress to the U.S. Army Corps of Engineers as part of the Flood Control Act of 1928. This was after the devastating Mississippi River flood of 1928, where the Congress authorized the Army Corps to begin making improvements on the Mississippi River for navigation and flood risk management purposes. So our responsibility or purpose is to provide, as I said, a safe and reliable navigation channel, and our authority for that, as given by Congress on the lower Mississippi River above the city of Baton Rouge, Louisiana, is a authorized 12-foot deep by 300-foot wide navigation channel. That is the authorized channel for the lower Mississippi River. However, at the present time, the Congress has only authorized funding to help the Army Corps, to require the Army Corps to maintain a 9-foot deep by 300-foot wide navigation channel. And keep in mind that we are required to maintain this 9-foot deep by 300-foot wide navigation channel at all stages and in all areas along the lower Mississippi River. So not only are we given this authority, but some of the other purposes, of course, are to increase the capacity of the channel for moving the water, to protect other project features such as levees, flood control structures, and other features along the river. And again, we do all this in an environmentally sensitive manner according to environmental laws and regulations. Some of our hidden infrastructure tools, as I stated: revetments, dikes, bendway weirs, which are a form of dike, and dredging. So revetments, dikes, and weirs are all considered long-term solutions for helping maintain navigation along the river. Dredging is a short-term solution that is used for navigation to help maintain the channel. The pictures that you see here are some of the construction that goes on along the lower Mississippi River. In the upper right corner there, you'll see a picture of a large excavator that's on a barge that is offloading stone onto a large off-road truck. and that truck is hauling the stone along the riverbank to be placed by smaller excavators along the bank. So that is placing stone along the riverbank for bank protection. The lower picture that you see here is a picture of the Army Corps of Engineers mat sinking unit. And this is a large government-owned piece of plant that works on the lower Mississippi River and places articulated concrete mattress, which is part of the revetment process. I'll be discussing the mat sinking unit and the revetment process in the upcoming slides. So first, let's talk a little bit about revetments. What are revetments and what is their purpose? Well, as I stated earlier, revetments are a infrastructure feature that's a combination of concrete and stone. These revetment features, structures, are the first line of defense in the river itself to help protect the Mississippi River levee system. So they are the first line of defense to help maintain the navigational alignment of the riverbank itself. They also assist in keeping some of the excess material out of the channel and to help us maintain that favorable channel alignment and depth. So again, our objective with revetments is a threefold purpose. We want to preserve the favorable bank alignments, provide efficient cross-sectional areas, and then help prevent the river from creating new meander patterns. Because as I stated, a river in its natural state, as I'm sure you're all aware, wants to meander. And so our job as engineers and as the Army Corps is to help train that river as best as possible and guide her along her way as she makes her way downstream. This is a picture of a bend in the river, lower Mississippi River, at river mile 643, which is roughly 300 miles downstream of the confluence of the Mississippi River, just south of a city called Helena, Arkansas, along the Mississippi River. As you can see in the photograph here, this bank is very ragged. As you can see, you have lots of in and outs along the water line, and this is not a favorable situation for the Army Corps. We would like to see a smooth bank alignment in this area, and so the way that we help address this ragged bank is by placing articulated concrete mattress and stone along the riverbank. And as you can see in the upper left here, that is the Mississippi River mainline levee. So we have areas here that are very close to the levee itself. I think someone had a question there. I'm not quite seeing it, but Jeff, can you tell us what that question was, and I'll see if I can try to address it?
Yes. The question was for the previous slide, and the person is asking, can you talk more about what we're looking at on the picture on the left in the revetment slide? And I think that was the slide.
Yeah, this slide here. So yeah, what you're looking at on the okay. On the left. What you're seeing there, on the left, this is a picture of the mat sinking unit deck, and the articulated concrete mattress that is on the deck of the mat boat. And so I'll be talking about that here a little more in the next few minutes. But what you're looking at on the left there is the plan itself, the mat sinking unit. And on the right there is just a rip-wrapped bank that is protected after the articulated concrete mattress is placed. So I'll be discussing that more here in the next coming slides. But again, there on the left is the mat sinking unit. You're very welcome. So moving on, let's talk a little bit about revetment construction. So through engineering, through the process of collecting surveys along the river, looking at channel alignment, looking at depth, once the design engineers determine which locations require revetment, that begins our revetment construction process. So at each new revetment location, again, this is a picture from the bank of the river of the mat sinking unit out in the navigation channel, placing the articulated concrete mattress. But at each new location, the site is first cleared of trees and vegetation as needed. The riverbank is graded, meaning the material is excavated or smoothed out to a stable slope. Then the articulated concrete mattress is delivered to the site by barges. So the mat is placed on barges we have locations along the Mississippi River where we store the concrete mattress, where it's cast, where it's formed up and cast and stored for usage along the river. And so we have a casting field at each of the lower three districts: the Memphis district, the Vicksburg district, and the New Orleans district. So the ACM is delivered from those sites, loaded on this specially designed mat barge, the mat sinking barge. The units are then tied together with stainless steel wires into a single movable. It's the reason it's called articulated. It allows for flexibility, for stretching, for moving of the actual concrete. So it's not exactly rigid. It has actually some flexibility so that it'll allow the concrete to contour to the bank and to the river bottom. But it's wired together in sections that are 140 feet wide, and it's anchored with stainless steel cables into the riverbank. As the mat is assembled, the sinking barge moves out into the river along what's called a mooring barge. So the mooring barge helps the plant to stay in alignment and to maintain its position. But it's as it moves out, the ACM is launched off of the barge and onto the riverbank and the river bottom. So the placement of this mattress continues to beyond the deepest part of the channel, and then the mat sinking plant is moved upstream to lay the next section of mattress. So this process with each succeeding mattress overlaps the previous mattress, and that's done in a manner similar as like placing shingles on a roof. So there's an overlap of each section of mattress as the mat boat moves from downstream to upstream, and there's overlap. So once the ACM is in place, the areas of the unprotected graded bank above the water line are protected with graded stone. So the next few slides just show some photographs of some of the various processes related to the revetment sinking process. Again, each new revetment location is first cleared and snagged of trees and other vegetation as needed in advance of the bank grading operations. And the Army Corps makes every effort to not completely clear the bank of all large trees, but to try to preserve some of the larger trees. We only remove those that are necessary for construction operations. So you can see here we've got bulldozers and some excavators that are doing some clearing and grubbing of the vegetation and the trees. So we'll talk a little bit about bank grading. The bank grading is performed by a combination of a large hydraulic drag line or crane, which is the floating piece of equipment that you see in the center of the slide here. This is the bank grading unit. This is a large hydraulic crane or drag line. It's a government-owned piece of equipment that has an approximate 10 cubic yard dirt bucket. So that's a pretty large bucket. You can see here on the right, that's a picture of actually me standing inside of the grader bucket. So as you can see, I'm approximately 6'2", so a very large bucket that's moving a large volume of material. You can see in the lower left here a picture of that same bucket in action, moving some of the material from the graded riverbank. So again, the bank grading unit is used to shape the riverbank and grade the slopes to a desirable alignment and for stability as well. The bulldozers perform the majority of the grading and shaping of the bank above the water line, as you can see in the photograph here, whereas the drag line does the majority or all of the underwater grading of the slopes. This is again just another view taken from the bank, looking out of the actual drag line and in use and in operation. On the left there is also a mooring barge, and so this grader is mounted on a barge, and it moves perpendicular to the bank in and out. And the mooring barge there to the left that you see is used to help move the plant up and down and out, in and out along the riverbank. So once the bank is graded, there is a period of time that, depending upon the schedule, there's a period of time where the banks are left exposed. We typically, I guess I should have stated this at the beginning, the typical construction season for revetment and for mat sinking is in the late summer and into the fall of the year. And this is typically when the river itself historically is at its lowest point. We would like to have the river as low as possible when we are performing the mat sinking operations so that we get the best finished product possible. So this work is done during the typical low water season. However, as you may be aware, the river does fluctuate quite a bit, and so there's times when the river levels may come up and go back down, and so we have to have a way to provide some level of protection until the mat sinking unit gets to the site. So this is done just with some basic gravel. This is placed by an excavator or a drag line, and we put the gravel from water's edge at the time of grading in strips that are approximately 30 to 50 feet wide. And this, again, is just an interim small level of protection of those freshly graded riverbank slopes. So this is a slide of the revetment operations itself, just a graphic that depicts, again, the overall sinking processes. So again, not to go, I've basically talked about all of these, but you've got your mat boat here with a supply barge. This is where the mat is placed from water's edge all the way down, and it's roughly 200 to 500 foot long out from where it starts on the bank out to the end out here. Above that, again, we place upper bank paving. You have a mat boat and a supply barge. And these steel anchors, the one thing I'll note is these steel anchors are driven with anchor plates along the riverbank at connection points, and they're driven 10 to 15 feet in the ground. And basically, they provide a way for the mattress to connect into the riverbank and stay in place. The size of the stone that is placed for the riprap upper bank paving from the limit of the mattress to the top of the bank is approximately 250-pound maximum, and we place it in a thickness of approximately 18 inches thick on average in the above the water line. This is just another picture. This is a good photograph of the articulated mattress coming off of the mat deck, and as I stated, as they tie these mats together, they back away from the riverbank, and it comes off of the mat boat, sort of like maybe as you're laying carpet or pulling a window shade down. And as you can see, the mattress itself is very flexible, and it contours and shapes to the riverbank. I think in the interest of time, I'm going to skip these videos. I have several videos of the mat sinking unit in action. I'm not going to play those at this time, but I believe that they have been put out on a website for you guys to download and look at them later. What you will see here is just a video. What you'll see here is a video of the overhead cranes that are used to pick the mat up off of the mat supply barge and onto the deck of the mat sinking unit. Again, this is just a video of the revetment sinking. So the previous picture where you saw it coming off the deck of the barge, you'll see that here in this video. Again, finally, as I stated, the last part of this revetment process is to place the riprap upper bank paving above the water line on the freshly graded riverbank slopes. Now I'm going to transition over quickly and talk about river training structures, which are other features of that hidden infrastructure. So river training structures are navigation features that are constructed of stone, and they are used to contract the channel with and scour the riverbed to the desired depths. So there's several types. We have transverse dikes. Transverse dikes on the upper left corner here are these stone navigation structures that are built perpendicular to the flow at various heights relative to the riverbank, and they force energy or the flow, the force of the energy of the water away from the bank and towards the center of the channel. And this is used to scour the riverbed and help provide that depth and width that is needed for that 9-foot deep by 300-foot wide navigation channel. We also have other dike features that are called lateral or trail dikes, and that's in the upper right-hand corner. These are stone dikes that are built parallel to the flow of the water itself, and they act sort of as an off-bank alignment for the channel. We construct these in bends of the river in some areas where there's excessive width, and they kind of serve. The purpose of them is to serve as a bank alignment for the edge of the navigation channel. The lower left here is a Benway weir. Benway weirs are dike features or stone navigation structures, but these are structures that you actually never will see. You can see in the graphic here that you've got a towboat with barges that are navigating over the top of these Benway weir features. These are, again, as I stated, they're built low, roughly 20 feet and lower below our ordinary low water stages, so that there's really never an opportunity for them to be hit by a vessel. And the purpose of them is they're built in benways of the river at angles upstream to perpendicular to the flow, and they are used in areas where we need more width in the channel. They scour the bed. There's deep water off the ends of them, and what they actually do is they slow the water down near the bank, and they make it easier for towboats to navigate that area. The last photograph here on the lower right, those are hard points. Those are essentially small dikes, mini structures. They are shorter structures that are built perpendicular to the flow to help force energy away from the bank, and they're typically 30 to 50 foot in length, whereas the other dikes could be several hundred to potentially several thousand feet long. So again, I've got some photographs. I basically talked about dikes. This is an aerial photograph of a dike field. Here's an overhead view of some dike construction with the barges of stone. And here's a view of dike construction in action. This is basically a method of dike construction where the rock is pulled off on the alignment of the structure itself, and that's called a drag-off method. It's done by a large excavator or a hydraulic drag line. There's a photograph of a drag line, and something to note, the difference between the previous, this piece of equipment here is using what's called spuds, and spuds are long pieces of steel that are movable, and those are used to anchor that equipment barge in place, so they go down to the bottom of the river. So in areas where the river is too deep for the spuds to reach the bottom of the river and hold the equipment in place, they use anchors that are placed in the bottom of the riverbed and are used to hold the equipment in place. This is a cool photograph. This is just a depiction of the large graded stone A, which is a maximum of a 5,000-pound stone. That is the primary size of stone that is used for constructing dikes. And as you can see, there are some boulders in this stone that could be as large as a man. I have a video for dike construction. Again, you can download that and view that placement of stone. I've already talked about Benway weirs. So everything, as I said, we do is done in an environmentally sensitive manner. These are a couple of the endangered species that we are required to maintain and to assist in keeping the habitat viable. You've got, of course, our bald eagle. The picture on the right there is a picture of an endangered fish called the pallid sturgeon, which lays its eggs in the river and is an endangered species. And the lower left is an interior least tern, which is a bird that lays its eggs on sandbars and nests on sandbars. We have to protect that species. And the lower right is a freshwater mussel that is called a Patalamus capax, or a fat pocketbook mussel. So the way that we do that, we incorporate environmental features into our dike designs. We basically, they're called notches. And what notches are just the degraded portion of the dike that would allow flow to pass through the structure during certain stages. And we do this to just allow for flow in some of these back channels in some of these areas where these species habitats are located. So again, as the water stages drop and navigation needs immediate assistance for the proper draft, the short-term solution is dredging. And I'm going to turn this over to Ms. Vicki Watson, who is an operations project manager for navigation here in the Memphis district, and she's going to talk to you a little bit about the dredging part of our project.
Good afternoon. Yes, my topic is very specific to the navigation channels. You want to hit the slide? Thank you. The main stem dredging, once again, is the channel improvement dredging, and we call main stem is the Mississippi River itself. Along the Mississippi River, we use government-owned motor vessels. We have the dredge Hurley and the dredge Jadwin, which are dustpan dredges. Basically, they have a device underwater that hoovers or vacuums along the bottom of the river and discharges out through a pipe back into the river. But we're trying to maintain the navigation channel. Chris mentioned earlier the draft of the water. We're trying to maintain a 12-foot channel in the main stem or the Mississippi River. Another type of motor vessel we use is the dredge Hurley. That is the hopper dredge. It is also a similar type of dustpan dredge, but it maintains the material inside of the vessel where it contains it and then hauls it off to another location to dispose of the dredge material. We have 12 harbors in the lower Mississippi. This is photographs of 9 of them. They are all shallow draft. We maintain navigation channels of less than 12 feet. The harbors go all the way from Hickman, Kentucky on the upper portion, all the way down to Vicksburg, Mississippi. Some harbors are natural harbors where the river meandered previously, and now they are shallow draft harbors. Some we have constructed. There's a photograph of New Madrid County Harbor. That is a harbor that the Army Corps of Engineers constructed several years ago. So we have navigation channels in all of those areas. In the harbors, we actually prefer to use a dredge called a cutter head. If you think of a beater like a mixer, and the mixers that are attached to it, and then apply teeth to those mixers, this material goes along the navigation harbor and it's chewing up the material that's deposited. Zach mentioned earlier that there is 240 million tons of sediment that flows down the Mississippi River, and as the river fluctuates up and down, a lot of this material is deposited into the harbors, and it's mostly comprised of sand and silt. So the cutterhead can go in there and chew up this material. It mixes with the water in the harbor, discharges it through a pipeline, and in some areas we discharge back into the Mississippi River in areas known to have swift current and much deeper areas. And then in some areas we actually have upland disposal areas. Now the advantages to a cutterhead is the material is conveyed through this pipeline, so we can move the material where we need it to go. The cutterhead also works much better with defined profile channels. Some of our channels are 250 foot wide, some are 150 foot wide, but the way the cutterhead works is it swings back and forth left and right so that we can define how far we want them to maintain the width of the channel. And then these cutterhead dredges also work much better in areas of shallow water. And because the river can fluctuate in our area anywhere from 0 to 50 feet, these cutterheads work better when the water is at a much lower level. Disadvantages to the cutterhead is they are limited to depth. So if the water rises too much, we would have to halt dredging until the cutter head could reach down to the bottom again. We are also diluting the dredge material with a lot of the river water. So in areas where we have containment, we have to allow for the water to settle and drop out the material because there is a high dilution rate. The distance in which the dredge can pump the material can be expensive if you have to have several thousand feet of pipeline. And then mobilization. It is not unusual when we do a contract dredge that the mobilization, demobilization charge is $1 million. So that $1 million is paid before any dredging can be done in any of the harbors. And before any dredging can be done, we also have the environmental sensitivities. Dredging cannot begin until July 1st. We have to consider the endangered species of pallid sturgeon. And so we are required to wait to dredge until July. We also have to maintain permits from each state, letting them know where we plan on placing the dredge material, either back into the river or into the containment areas where the water eventually comes back out of the containment areas and the sediment is left in the levied areas. I know that was very quick, but I know we're limited on time, so I will transfer it back to Elizabeth.
Thanks. Real quick, we really appreciate everyone's time and interest in the Mississippi River. I have a couple more slides that I think will help pull it all together real quick if you can stay on. First, infrastructure brings value to the nation. I think we've talked about that with flood protection and navigation. You saw the infrastructure in the with dikes and revetment, and also short-term solutions with dredging. What I really want to draw your attention to is this bottom information where it talks about corn production. Here there was something published in 1996 for prices of corn, and it shows the difference in production between Iowa and Argentina. And you can see as far as growth and harvest, it's a lot cheaper to produce corn in Argentina, but when you add transportation costs in there, it's your total to market price is going to be a lot cheaper if you if you grow, harvest, and transport in the U.S. than you would in Argentina. So for Iowa corn, your total cost was $3.01 versus Argentina $3.21. So as far as world economics, our transportation costs provide a better efficiencies to get our goods to market. So that's really, in a nutshell, shows you why infrastructure is so important on our waterways. The next slide just talks a little bit about what Vicki mentioned, the fluctuation in our rivers. On the left, we show a picture of Memphis. There was a historic flood in 2011 throughout the lower Mississippi Valley. And this was just a good snapshot for the Memphis area, but a flood in 2011 and a massive drought in 2012. And you'll see below the stages where we had a 48 stage in 2011 during the flood, and then a -9 stage in 2012 during the drought. So elevation difference of roughly 60 feet. There are not many rivers that can handle a fluctuation of 60 feet and continue to be reliable. All right, next slide. And this is our last slide. Because we have infrastructure and bring value to the nation, because we are that economic artery, because we can provide reliable waterways to get our goods and commodities to market, we're a worldwide leader. And we're working with other countries to share our lessons learned on developing watersheds. So these are just a few pictures. The top two slides, or top two pictures, are of the Mekong in Southeast Asia, particularly in Laos PDR. And then bottom left, you have, we're actually in the Amazon right now. We have a crew working there with their government in Brazil. And then on the lower right, we were working in Thailand. So as we've developed our rivers, we've done great things, we've done not so great things, but we continue to learn from those, and we continue to have the best waterway system in the world, and we try to share that with other nations around the world. So we really appreciate your time. Thanks so much. I know everybody is limited in time. We're happy to stay on and answer any questions, but we'll turn it back over to you, Jeff.
Well, thank you very much. I'm not seeing any questions that are coming in right now. I've unmuted everyone's lines. Does anybody have a question that they would like to ask? Okay, maybe we shouldn't have unmuted everybody's lines. Does anybody have a question that they would like to address in the chat box? Well, while we're waiting to see if there's any questions, I just want to thank each of you for taking the time to present to the young members today. This has certainly been very fascinating, and you're right that a lot of this infrastructure is really hidden. Even the ships that we see out on the river, they're moving so silently, we're probably not even thinking of it. So it looks like we do have, there are some comments coming in, no questions yet. But I would like to encourage everybody in the email that I sent out this morning with the links for the presentation. There were also links to see the videos that Zach was mentioning that we were unable to see. But definitely check that out to see the articulated concrete mattress in action.
Okay, Jeff, I think we have a question here. The question was about government-owned versus contractor owned equipment and who runs it. So the actual mat sinking unit itself and the bank grading unit and all of the attendant plant, the dredges, all of the plant from our presentation today, that is all government-owned property, government-owned vessels and equipment. So the process is kind of unique. I mean, the Army Corps and the U.S. government does a ton of contracting, of course, on the lower river and the waterways. The construction of the dike features that I discussed, that is all done by contractors, by private contractors. But the revetment process and the dredging operations, those are all using internal government-owned personnel and equipment.
Excellent. That was one of the questions that I had as well. Well, it looks like we don't have any additional questions coming in, so I'd like to thank each of you for spending your lunchtime with us and sharing all of this great information with us. We do have another question coming in. Are you able to see that? The question is, graphically, where are the revetments typically located? Are there more further downstream, or are they more evenly distributed along the entire lower Mississippi River?
It varies from district to district. I would say on the whole, they're probably spread out equally among the lower three districts, the Memphis, the Vicksburg, and the New Orleans districts. What you're going to find out if you are ever on the lower river is for navigation purposes above Baton Rouge, you'll see a lot more dike features, a lot more of those stone navigation features that are constructed to help us maintain the navigation channel. When you get below Baton Rouge, you get into the deep draft channels for the ships that are bringing in cargo from overseas and shipping cargo out of the port of South Louisiana and New Orleans. And so you've got the huge ocean-going vessels. And when you get below New Orleans, the channel there, not to go too much into it, but the Army Corps maintains like a 45-foot deep channel by 500-foot wide below Baton Rouge. And so there's not a lot of dike features there. There's mostly just revetment banks to protect the bank from erosion. So, but I would say on the whole, across the lower three districts, there's probably approximately the same amount of revetment on the riverbank.
Excellent. Thank you for addressing that. Well, thank you once again. For everybody that is still with us on the call, I want to remind you, as Lisa mentioned, that we have our next council call next week on Thursday, the 14th of December. We'll be using the same teleconference line and the same connection. And reminder that if you're interested in speaking at the upcoming JETSI conference, please be lookout for the Young Member Council's offer to review and help mentor you through that process. And our next professional development call will be coming up in March, where we'll be discussing networking just in time for JETSI. And if you have any future topics that you would like to see being addressed on these professional development events, please be sure to share those with us. We'd love to to see what you're interested in and help share that information. So thank you once again for joining us, and thank you especially to our speakers, Elizabeth, Vicki, Chris, and Zach. This has been very, very interesting information, and a lot of information that just washes right by us every day and we don't even realize. So thank you.
Thank you for organizing this and inviting us.
Okay, well, at that, we'll call this a day. Thank you, everyone.